we're going to look at a bit further into solving cubics, and cubic equations. Sometimes, if you're lucky, you can use a type of grouping a little bit reminiscent of what we did with quadratics, but this doesn't always happen. You've just got to see if there is actually something you can group. You might remember when we were factorizing quadratics, we would get basically a pair of brackets, a pair of brackets, and there might be something plus or minus in the middle, and if you use the decomposition method, you could see that what goes in the first set of brackets goes in the second, okay? And then when you see that, everything's great and you're happy. So can we do that with this one? Well, we can. So what we need to do is see what groupings are available. Now we've got, if we look closely and we look at x minus 4 could work in here. Something along the lines of that if we look closely at the pattern. So if we look at the first two terms and then the second two terms, like that decomposition method, you can see that if we have x minus 4, what factor would we need out the front of here? Well, what about x squared? That makes the first term work. X squared times x is x cubed, and x squared times negative 4 is minus 4x squared, so that works there. Can we get something out the front here? So if we put in minus 11, does that work? Minus 11x and minus negative 4 is plus, minus 11 times negative 4 is plus 44, so yes, that works, and we'll get x squared minus 11, x minus 4 as factors, and that equals 0. So x equals 4 is one solution, and we have x squared minus 11 equals 0. X squared equals 11, so x equals plus or minus the square root of 11.